Hello, today we're going to talk about solving an isosceles right triangle using a very specific technique. We're going to use similar triangles and ratios. There are definitely other ways of doing this, but the technique we're going to use on these examples are going to be using ratios and similar triangles. So this might be something new for you. First off, let's talk about the isosceles right triangle, also known as the 45, 90 degree triangle. We'll find out where these ratios come from. You can see I start with a 45, 90 triangle named for its three angles. First, let's just label an unknown side as x. I don't know this side, but I do know that it's isosceles, so both of those are x. At this point, I can really just use the Pythagorean theorem to find the hypotenuse. So, as I plug in my a squared plus b squared equals c squared, I've got x squared plus x squared, which of course is 2x squared. When I take the square root of 2x squared, I get x times the square root of 2. Therefore, my hypotenuse is x square root 2. So I just found out the hypotenuse is the square root of 2 times the leg. Now, some people just use this definition, but what I want to do is I want to take this picture that we just have, x, and x square root 2, and I really just want to memorize it. Remember, if these two are the legs, that x is the same, so if this could be a 3, 3, and a 3, or a 7, 7, and a 7. So really, I just want to focus in on the ratios. So I want to memorize this 1, 1, and square root 2. So when I'm looking at a 45, 90 triangle, I want to know the 1, 1, square root 2. Now, how does that help me? Let's look at an example and see. So there's really about two examples we can look at. Here's one of them. When I happen to know a leg of my 45, 90 triangle. Again, there are other techniques to use, but I'm going to focus in on using ratios. So, as we just practiced, I know that this 1, 1 square root 2 triangle, I know that these two triangles are similar to each other. The angles match up by angle-angle similarity. Therefore, I also know the sides are proportional. So I'm going to set up proportions. I know that 8 matches the 1, just like the x is going to match the square root of 2. And with that being said, now I have a proportion. I can cross multiply and divide, and you can see clearly that the answer is 8 square root 2. Another example. This time, instead of knowing a leg, I now know the hypotenuse. Well, the two legs are missing. So, again, I want to focus in on the 45, 90 triangle of the ratios 1, 1, square root 2. Again, I know that these triangles are similar, which means they're proportional. So I can set up a proportion. This time my x matches a 1, just like the 9 matches the square root 2. From that point, cross multiply and divide both sides by the square root of 2. Now, here's where you have to read your directions carefully. If I'm doing a word problem or something, I can just simply type 9 divided by the square root of 2 in my calculator and approximate it as 6.4. However, sometimes if we're studying trigonometry, or we've got that really strict algebra teacher who wants us to do it in simplest radical form, I'm going to have to rationalize this denominator. So that's going to be where I multiply by the square root of 2 over 2 to get the denominator to clear out. It leaves me 9 radical 2 over 2. Again, that's the answer I would use for a trigonometry question. This is the answer I would use for a word problem. I hope that was helpful. I do recognize that there are other techniques for solving the 45, 90 degree triangle. However, I wanted to focus this video on solving with ratios and similar triangles.